Hello, Accelerated Math 7-8 students. We are working in Module 12, and this is Lesson 10. And Module 12, Lesson 10 is called Properties of Dilations. And so we'll go ahead and get the notes that we're going to work with today. Properties of dilations. So our goal for today we will learn how to perform dilations. The question that I want you to think about during the lesson is, what does it mean for two geometric figures to have the same shape but not necessarily the same size? Things to know. Properties of dilations. First off, I need to tell you that a dilation is the fourth type of transformation that you're going to work with in this geometry module. A dilation is a change to a figure, but the thing that you need to know about dilations that makes it different from the three other rigid motions that we've been learning is the three other rigid motions that we've been learning preserves the shape and the size of all the figures when they are changed. A dilation, however, does not. Okay? What it does do is it preserves the shape, but it does not preserve the size. So a dilation is a transformation that produces an image that is the same shape as the original, but is a different size when it's finished. A dilation that creates a larger image is called an enlargement. A dilation that creates a smaller image is called a reduction. A dilation stretches or shrinks the original figure. And so dilations change figures by changing the size of the figure. The shape remains the same, but the size is what changes. You have to have a tool when you are working with dilations, just like when you're working with reflections, you have to have a line of reflection. When you're working with rotations, you have to have a center of rotation. And with a dilation, you have to have a special tool also. And the tool that you have to have for a dilation is you have to have a center of dilation. Okay? You also have to use a scale factor. A description of a dilation includes the scale factor or ratio and the center of dilation. So it actually has two tools, the center of dilation and a scale factor. The center of dilation is a fixed point on a plane. We're talking about like the coordinate plane. If the scale factor is greater than 1, then the image is considered an enlargement, a stretch. And if the scale factor is in between 0 and 1, or what we could also say is less than 1, the image is a reduction or it shrinks. Okay? If the scale factor is 1, then the figure itself and the image are congruent because they'll be the exact same size and the exact same shape, so that makes them congruent. So this picture right here in your notes is a picture of a dilation. Obviously, triangle ABC is the pre-image because it doesn't have any prime notation saying that it has been changed. The O right here tells you the center of dilation. So you start from the center of dilation and you see how the original pre-image changes to become enlarged with the dilation taking place. Just by looking at this picture right here, you can tell what the scale factor is. And the answer to figuring out what the scale factor is that you have to recognize that it's an enlargement, so it must mean that the scale factor is larger than 1. Notice that we put the prime notations on the labels of the image so that you can have the definition that the image is a result of a transformation known as a dilation. Okay? So you're starting to build on your knowledge of all these different transformations, and that's what you have to remember. All right, I have one that I want you to try, and we're going to take a look at it when we get into class together. But the one that I want you to try is, this is a figure. Okay, it kind of looks like a Pac-Man. All right, so here is your little Pac-Man guy. The points that I want you to be very careful with is this is point A, this is point B, and this is point C. And it says use the scale factor to determine the dilation. The scale factor is 3. So what you're going to do, this is your center O right here. So what you're going to do is you're going to figure out the distance from the center O to A, the distance from the center O to B, and the distance from the center O to C. And we always call the center of dilations, most of the time they call them O's. So I'll write in this O. Sometimes they give you a different name, but the majority of the time it's O. So you're going to make a line using your ruler from the center O to A and figure out what it measures. And I would like you to work with centimeters. Okay, so you're going to measure it in centimeters first. All right. Then you're going to measure from O to B in centimeters. Then you're going to measure from O to C in centimeters. Then what I would also suggest that you do is using that ruler once you figured out the distance, I would go ahead and pick this center O and this point right here on A, and I would draw a line straight through, okay, going as far as you can off of your paper. Then go from the center O through B, going as far as you can, and then from the center O to C, going as far as you can. By doing that, you're setting a route for yourself to transfer your new image to. So once you figure out what the segments are, so we're going to do the length of OA, you're going to figure out the length from OB, and you're going to figure out your length from OC, and you're going to figure them out in centimeters. Then you're going to take your scale factor, which is 3, and you're going to multiply the scale factor by each one of these lengths. So if OA is, let's say, 7 centimeters, then you would take 7 times 3, and you would know it's 21 centimeters. So you're going to come out here to where it says 21 centimeters, and you're going to draw a little point, and you're going to name it A prime. Then you're going to figure out what B is. Let's say OB is 5 centimeters, so you're going to multiply it by 3. You're going to come out to 15, and you're going to put a B prime. And then you're going to measure OC, and you're going to say, okay, maybe that one is 8 centimeters, and you're going to multiply it by 3, so you get 24. So you're going to come out here to 24, put a point, and that's going to be C prime, and then you're going to connect your points, making your image of the dilated figure. Okay? So I'm very interested to see how it goes, to see what you come up with, and we'll go from there in class. All right, let's go back to our goal. Our goal for today, sorry, I have to look that up, is we will learn how to perform dilations, which I just showed you how to do that. The question, what does it mean for two geometric figures to have the same shape but not necessarily the same size? What it means is that they have been dilated, okay? This is pretty fun. It's pretty simple. You got to make sure that you have tools, though. So you're going to need a ruler, and then you need to be able to remember how to apply scale factors. Enjoy it. Have fun with your image of your pre-image, that little Pac-Man guy, and I'll see you all later. Bye!